The topic is error detection and correction. Error detection is the detection of errors caused by noise or the other impairments during the transmission from the transmitter to the receiver. Error correction is the detection of the errors and reconstruction of the original error-free data. So what is error detection and correction? Whenever we send the data from one system to the other system, or you can say sender to receiver or transmitter to receiver, there might be a number of chances that some errors can be occur over there due to the some external impairments or some external noise. If that noise is mixed with our data, or due to some impairments, whenever the external sources they are mixed with our data will automatically change. We also know that we send the data. Whenever we send the data should be sent in the form of bits, either in the form of zeros and ones. Whenever the value of zeros and ones changes, this becomes that some error is present over there. And to find, this is called the error detection. And to find that error with the help of some techniques and try to reconstructions of the original data, that is called the error free. This technique is known as the error correction. Now we are going to read out the concept, the error detection and correction. So first we have to know about the types of errors. The errors can be of the three types. The first is the single bit error, second multiple bit error, and third burst error. First is the single bit error. As the name implies, single bit. In the received frame, only one bit has been corrupted. That is either changed from 0 to 1 or from 1 to 0. This is called the corruption of the bits. Whenever bits changes its value, it means the complete meaning of that message will be changed. So this is known as a error. The first is the single bit error. Now look at the diagram, the send frame. Whenever we are going to send the frame, the value consists of these frames are 1, 0, 0, 1, 1, 0, 1, 0. But at the receiver side, the value of this frame is 1, 0, 1, 1, 1, 0, 1, 0. So the frame that is available on the third slot, when we send the data, its value is 0. But when receiver receives that frame, the value is 1. So this is called the error. This is called the error is present in the frame, or you can say the error is present in our data. This is called a single bit error, when only the single bit changes its value. Next, multi-bit errors. In the received frame, more than one bits are corrupted. Whenever a more than one bits are corrupted in the frame, this is called the multi-bit error. As shown in the figure, the 3 bits on the different locations, it changes its value. The first bit is on the third location, the value of the 0 changes to the 1. Then on the 5th location, the value of 1 changes to the 0. Then on the 8th location, the value of 0 changes into the value of 1. And the last one is burst error. In the received frame, more than one consecutive bits are corrupted. More than one bits are there, but these bits are consecutive bits. Consecutive means in a serial order. Consecutive bits are changes their value, then this error is known as the burst error. As shown in the figure, the consecutive 3 values are changed from 0 to 1, from 1 to 0, and from 1 to 0. So these are the different types of errors are available. Now the next is error detection techniques. There are 3 main techniques for detecting errors in a frames. That is, the first is parity check, then checksum, then CRC, that is called cyclic redundancy check. Now let's start with the first one, that is parity check. The parity check is done by adding an extra bit called parity bit to the data to make a number of ones either even in the case of even parity or odd in the case of odd parity. While creating a frame, the sender counts the number of ones in it and adds the parity bit in the following way. So it is a very simple process. Suppose I want to send the data towards your side and I'm using the parity bit for error detection method. by your side, then simply I can add. Either I go for the even parity or the odd parity. Even means when to make the number of ones in your data even. If they are not even, simply add the one. If you are add the extra one. Actually, we calculate the number of ones and make the number of ones even in our data with the help of this. If we are going to for the odd parity, we count the number of ones and make the number of ones odd in the particular data frame. And while creating a frame, the sender counts the number of ones in it and add the parity bit in the following way. What is the first way is, in case of even parity, if a number of ones is even, then the parity bit value is 0. Why the 0? Because we are using the even parity and already the number of ones are even. So we simply add the 0. So still the number of ones remains the even. But if the number of 1 is odd, then the parity value, the parity bit value is 1, because the number of ones are odd. Whenever we add an extra bit, then number of ones become even. And same in the other case, in the case of odd parity, if the number of ones is odd, then the parity bit value is 0. If the number of the one is even, then the parity value is 1. So what will happen? We make the count of 1 in our data either the even or the odd. The second is checksum. In this error detection scheme, the following procedure is applied. We have the following methods to apply under the category of checksum. First, data is divided into the fixed size frames or segment. First, we can divide the data into the fixed size. The sender adds the segment using the ones complement arithmetic to get the sum. Now, of these fixed sized segments, we are calculating the ones complement of that particular segment. Then it complements the sum, then again complements the sum to get the checksum and sends it along with the data frame. What will happen? The first, you can divide the data into the fixed size segments. Now count the ones complement. Now after complement of the ones, we get that complement. This is also known as checksum, and we can add that value along with the original message and sends to the sender's side, receiver's side, sorry. Or the receiver adds the incoming segments along with the checksum using the ones complement arithmetic to get the sum and then complements it. What it means? Now suppose I am the sender, I have the message, I divide it to the fixed size variables. Now calculate the ones complement of this data, add that complement with data and sends to your side. You receive that message, you again calculates the ones complement of data, ones complement of data is there, and you can make the sum of this ones complement. If now again the value remains the same, because whenever you count the ones complement of data, again the previous value comes at your side, then what will happen? If the result is 0, the receiver frames are accepted. What it means? There is no error, otherwise they are discarded. Clear? And the last one is the CRC, that is called cyclic redundancy check. Cyclic redundancy check involves the binary division of the data bits being sent by a predetermined divisor agreed upon the communication system. The divisor is generated using polynomials. What it means? CRC uses the binary division of data bits. They are using the binary division, but the division can be done with a predetermined divisor. The divisor, on that divisor, the sender and the receiver are agree on this divisor. They can divide the particular data with that divisor and calculate the value. The value that is remaining, it is called the CRC, and that is added with your data. Let's start this. Here the sender performs the binary division of the data segment by the divisor. First you perform the division with the predetermined divisor. It then appends the remainder. What is that remainder? Either x, y, z, any value is there. That remainder is called CRC. CRC bits to end of the data segments, and we can append the remainder called CRC. What is the remainder? We add that remainder with your data and sends that particular data towards to the receiver side. This makes the resulting data unit exactly divisible by the divisor. Now, the new number that is exactly divided by that particular divisor. But at the receiver side, the receiver divides the incoming data unit by the divisor. If the no remainder is there, the data unit is assumed to be correct and is accepted. Otherwise, it is understood that the data is corrupted and therefore it is rejected. So receiver receives the data. They can again divide it with the predefined divisor. If the remainder is zero, then they can accept the data. Otherwise, they can reject the data. Okay, the next is now we have the error correction techniques. Let's start with the first one that is defined in our syllabus. The Hamming code is a block code that is capable of detecting up to the two simultaneous bits errors and correcting single bit error. It was developed by the R.W. Hamming for error correction. Now the first is, or the code for the error correction is Hamming code. Basically, Hamming code is working on a two simultaneously bits. If the two simultaneous bits are changed, they are working on this, or if the single bit error is there, then we are using the Hamming code. In this coding method, the source encodes the message by inserting the redundant bits within the message. We can add some extra bit with the message. These redundant bits are the extra bits that are generated and inserted at the specific position in the message itself to enable the error detection and correction. When the destination receives the message, it performs the recalculating to detect errors and find the bit position that has errors. So how the work is done in the Hamming code, we simply add some redundant bits, and these redundant bits means we are simply add some extra bits with our data and sends towards to the receiver side. Whenever receiver receives the data, they calculate the redundant bit and check the positions of the remaining bit whether there is some error or not. So we have the encode. Now we are going to encode a message by the Hamming code. A step-by-step approach is there. The procedure used by the sender to encode the message that encompasses the following step. How this can be done at the sender's side. First, calculate the calculation of the number of redundant bits. First, I have to calculate the number of extra bits. That depends upon me that how many number of bits we are going to be added in our data. Second, positioning the redundant bits. Now, select the position of these extra bits into a particular frame. For example, either you are going to fix the first redundant bit at the third position, then seventh, then ninth, then 10th, this one. And third, calculating the values of each redundant bit. And now we are going to calculate the value of every extra bit that we are going to be add in the Hamming code. Clear? Once the redundant bits are embedded within the message, this is sent to the users. After completing these three steps, we are having a new text is there. Now we are going to send that message to the receiver side. Clear? Now we send the data. Now the data is received by the receiver side. What will be happen at the receiver side? Now they are going to decode the message. At the sender side, we encode the message, and at the receiver side, we decode the message. Once the receiver gets an incoming message, it performs a recalculation to detect errors and correct them. And what are the different steps to recalculations are? We have the 4 different steps. The first is calculation of the number of redundant bits. First, the receiver can calculate the total number of extra bit or redundant bits. Suppose the 5 extra bits are added. It can first calculate the number of bits. Suppose at the receiver side, the number of redundant bits are 5. Now, at the second step, positioning the redundant bits. Now, the receiver check the position of these 5 bits in the particular frame format. Third, parity checking. Now it can check the parity. Parity means either the even parity is there or the odd parity is there. At the fourth side, error detection and connection. After come out the parity, suppose if the even parity is there, after come out with the even parity or with the total number of ones that are extra added into that particular message, depends upon these positions and the number of redundant bits, they can simply detect the error by comparing it with the original data, and wherever the error is occur, it simply correct these errors. So this can be happened in the receiver side, and this is called the decoding of the message in a Hamming code.